You spend hours perfectly aligning a desktop layout. Then you pull it up on a phone and the structure shatters. Text overlaps, boundaries fail, and the design collapses into a chaotic mess. Take a look at the navigation bar. That horizontal row of links that fit beautifully on a wide monitor is now squeezed so tightly you can't read the text, or it spills entirely off the right edge of the glass. You don't have to throw the code away and start over. The solution is retrofitting, layering a few specific rules onto your existing code to adapt it for smaller screens. This is how most real-world development actually works. You are rarely building from a blank slate. You are usually taking an existing desktop site and upgrading it to function for modern mobile users. By default, mobile browsers try to help out by pretending they are wide desktop monitors. They take your full-size site and drastically shrink the entire page to fit the narrow screen. This graphic shows the absolute prerequisite for responsive design, the Viewport Meta Tag. Setting the width to device width overrides default shrinking behavior. It forces the browser to render the page at the physical width of the phone's screen, locked at 100% zoom. You need to copy this exact line of code and paste it into the head section of every single HTML page on your site. If you skip this step, the device will never establish that true width baseline, and all of your subsequent CSS sizing rules will be completely ignored. Once the viewport is set, the next hurdle is your media. A fixed pixel image will aggressively push past the bounds of a narrow mobile screen, forcing an awkward horizontal scroll bar at the bottom of the page. This shows the two-line CSS rule needed to fix this issue site-wide. Setting max width to 100% acts as a strict boundary, shrinking the image to fit its container. Meanwhile, height auto ensures it scales evenly without distorting its natural aspect ratio. But Fluey images introduce a new problem: layout shift. As the browser waits to download the image file, it doesn't know how much space to leave empty. When the image finally arrives over the network, the entire page violently jumps down. This code block highlights the HTML adjustment required to prevent that jump. By hard-coding the natural width and height attributes directly into the image tag, you reserve the exact physical space before the file even begins to download. It is a strict division of labor. The HTML attributes reserve the invisible box instantly, while your CSS rules handle the dynamic shrinking if the screen happens to be smaller than that box. Locking down those image bounds and eliminating layout shifts turns a jittery web page into a seamless reading experience. Now that the mobile baseline is solid, you need a way to selectively change your layouts only when the screen gets wider. This infographic breaks down the anatomy of a CSS media query. Think of it as an if statement for your styling. You establish a breakpoint by defining an exact pixel width. If you want a layout to shift from a single mobile column to a desktop grid, you set a minimum width condition. The rules inside that query will only activate when the screen is at least that wide. Because browsers read CSS from top to bottom, you should place these media queries at the very end of your CSS file. This isolates your desktop styles and ensures they correctly overwrite the mobile defaults above them. Media queries never change your actual HTML. The underlying content stays exactly the same. The queries just act as a conditional lens, reshaping how that content is presented based on the user's environment. You can apply this breakpoint logic directly to your site's navigation. On a phone, a full horizontal row of links takes up too much valuable space, so the standard practice is to hide that list and reveal it only when a user taps a hamburger icon. To set this up, you first insert a button element for the icon into your HTML and ensure all of your navigation links are grouped tightly inside a specific container class. Next, you write a CSS rule to hide those grouped links by default. Then you create a new class, like .open, that overrides the default and forces the links to display vertically. This diagram illustrates the missing piece. CSS cannot detect a user's physical tap on the screen. To make the button actually work, you need a JavaScript file to actively listen for that interaction. This breakdown maps the exact flow between the three languages. The HTML provides the structure, the JavaScript listens for the click, and the CSS handles the visual change. When the user taps the icon, the JavaScript detects the click and dynamically injects the word open into the HTML class list. The CSS reads that new class and instantly displays the vertical menu. A second tap removes the word, hiding it again. CSS dictates how the interface looks, but JavaScript is required to make it function. Connecting the two marks the point where you stop building static documents and start building interactive web applications. This side-by-side comparison shows the results of a complete retrofit: the original rigid desktop layout on the right and the new fluid mobile adaptation on the left. Text remains natively readable without zooming. Images scale smoothly without breaking their containers. Horizontal scrolling is completely eliminated, and the navigation is tucked away in an interactive menu. As you apply this to your own site, verify your HTML head tags. The Viewport Meta Tag must be pasted into every single HTML document, not just your index page. Otherwise, the mobile experience will break as soon as a user clicks to a subpage. Mastering these core techniques, the viewport tag, fluid image bounds, and conditional media breakpoints, guarantees that your code will survive contact with the endless variety of real-world screens.